We're going to dive deep into regression, which is one of the most powerful tools that you're going to use as an educational leader. So we'll do this in a few lessons, and this is our introduction to regression. So what exactly do we mean when we say regression? You may have heard it before. Maybe you did it in high school or college in your master's program. Maybe this is something that you already perform on a regular basis. Regression is a model that's going to show the relationship between two variables. And these can be any two variables that we have solid data for. Another variable could be achievement scores, could be participation rates. We could do behavior regression. What we're asking is, how does changing variable X affect variable Y? So we're showing the relationship between two variables and asking, how does changing variable X affect variable Y? So why would we want to do this? This is going to allow us to understand large data sets, to learn which variables affect results and which don't. It's just as valuable to learn which variables do not affect results. Informed instruction is what we're looking for. It helps us know which factors are going to drive our student achievement, evaluate any trends from year to year on our student achievement, then accurately forecast scores and make predictions about the future. But we're going to take a step back. And we're going to walk away from school life and show you an example from a franchise. In this scenario, we're trying to understand variation in sales by looking at the following factors: the number of square feet, inventory levels, advertising spending, the number of families that are in the sales district, and the number of competing stores in the sales district. And in regression, we're going to use the following equation, and it's very simple. Y is going to be our dependent or the responding variable. A is going to be our intercept. B is going to be a slope coefficient that Excel will give us. X is going to be what's called the explanatory variable, and X is also known as the independent variable. And this E term are the residuals, or the error that we're going to look at. Movement in one variable is going to result in movement of the other variable, and we're trying to find how that relationship works. So again, the explanatory or the independent variable, that's any factor that's going to affect or change the responding variable Y. And Y is what we're measuring. It's the dependent or responding variable that is changed by any variation in the explanatory variable. How is student achievement score affected by the education level of parents? By participation in after-school activities, by achievement scores in other subjects, by participation in music, by participation in the school breakfast or the school lunch program. How is behavior explained by all of those factors as well, right? So we can start to take a look at all of these different ideas, and you can maybe see how this can be powerful. Now, the intercept and the coefficients are the other part of the equation. And the intercept is simply the value of Y when your explanatory variable equals 0. So that's just simply the value of Y when X equals 0. And your slope coefficient is the rate of change in the conditional mean of Y. And Excel is going to give you that number. When we're looking at two different variables and how they are related, we can create a scatter plot. And on this scatter plot, you can see all of these different data points along with our fit line. So right now we're looking at the variation in sales and the relationship of the number of square feet and sales. And we've created a scatter plot. You can see that most of the data points fit pretty close around that line. So this is something that's highly correlated. We can see that the number of square feet does in fact correlate with sales. And so what are those residuals? That's this last part of the equation, the error term. And residuals are data points that do not lie directly on the fitted regression line. So we can see that we have some data points that are going to be fit right on that line, and some error terms, some residuals that are not on the line. The sum of those is going to equal 0. And when we do regression, we're going to use something called least squares regression. And there's a few reasons for that. Least squares regression is going to help us find the best fit. It is going to minimize the distance between the regression line and those residuals that we just mentioned. So the standard deviation is going to be minimized. Remember, that is something that we want to do as much as possible when we're analyzing our data and making decisions based on it. And it's going to penalize any large errors. So this is just a little bit of introduction into the theory behind regression. And next we're going to talk about the process. How do we actually get from point A to B from our data to making decisions based on regression analysis?